second part of this problem, part B, says a tumor with 5,000 cells initially growing at a rate of 200 cells per day. Assuming the maximum size of the tumor is 100,000 cells, how large will the tumor be after 100 days? Okay, so first of all, what we're being asked to do is solve for the specific solution. So we are given P max, we need to solve for C2 and K. Okay, so that's the first thing we're going to do. So I'm going to first of all solve for C2 by using the condition at t equals 0, the population is equal to 5,000. Okay, so at t equals 0, p equals 5,000. So I'm going to plug that into my equation. 5,000 is equal to P max, which is 100,000. And that's going to be e to the C2. T is equal to 0, so this expression is going to be equal to 1. So I'm just going to change that to 1. And then we end up with C2, or e to the C2. So this becomes 5,000 divided by 100,000, which is 1 over 20. And that's e to the C2. So solving for C2, it's going to be the log of 1 over 20, which I'm going to convert to negative log of 20. Okay, so there's C2. I also need to solve for the K value. Now for the K value, they give you that the tumor with 500 cells is growing at a rate of, and this is important, a rate of 200 cells per day. Well, that's what this is equal to. That's my differential equation. It's equal to 200 cells per day. So then I'm going to rewrite this as the dp by dt is going to be 200 cells per day. When we don't know k, that's what we're solving for. The p at the present time is going to be 5,000. The P max was 100,000 minus log P, the P was 5,000 again. Okay, so when I write it like this, I now can have an equation to solve for K. So K is going to be 200 divided by 5,000. Put that together, 100,000 divided by 5,000 is 20. And so simplifying this expression, I am going to end up with 2 over 50. And then the log 20 goes in the denominator. And that's going to be equal to my K value. Now if you want, you can convert that to a decimal, but I'm going to just keep it in that form and put it into my equation. So my general equation now looks like this. Or sorry, my specific equation. So the specific solution is P of t is equal to 100,000. E, my C2 I figured out, solved for as negative log 20. E to the negative k, so k is going to be negative 2 over 50 log 20. Okay, and that's times by t. Okay, so there's my the equation that I'm going to use to calculate the P at 100 days. So this becomes 100,000 e to the negative log 20 e to the negative 2 over 50 log 20 times 100. Okay, we can simplify this a little bit, but basically we're just going to have to punch this into our calculator. This becomes negative 200 over 50, so negative 4 over log 20. And we need to then kind of calculate these little bits here, and using a calculator I get e to the negative log 20. This piece, whole piece, if I do e to that power, looks like it's about 0.263. Okay, when I work out the exponent part of this, I end up with e to the negative 0.7 0.878 approximately, and then this works out to be the solution, which was about 45,000. Okay, so I'm just going to type that to my calculator here. So e to the negative 0.78. I get about 445,400, something like that. Okay, so let's just round that to about, let's go 500 approximately, and this is based on some rounding that occurred in here, so the exact value is probably going to be just off by a little bit.